Okay, guys, today we are gonna wrap up our three-part mini series on operations of functions. So fun problem reads: use the graph at right to evaluate each expression. I'm gonna go ahead and use a highlighter to sorry for the redundancy, highlight these. So function f will be the pink one. How do I know if that's f? Because it says so, you know. Function g will be the line. Okay. How do I know? Same for the same reason. It's labeled as such. Okay. The computer doesn't know how to put arrows at ends. That's one of my pet peeves. Fantastic. So let's do this. So it says use the graph at right to evaluate each expression. So problem A, we want to add functions f and g, and once we do that, we want to evaluate that at 2. So what we're going to do is we're going to use the definition of the sum function. Okay. So we have this first function f, and we want to evaluate it at 2. The operation is plus, so we're going to add to it the second function, and we want to evaluate it at 2. Cool. So I feel like us applying the definition of the sum function is like the toughest part. The second part, you just gotta keep your cool. Okay, so f of 2. So when the input is 2, what is the value of this function, or what is the output? So this is how I do it. I locate 2 on the x-axis, and then we're gonna go up or down until we hit function f. So in this case, we're gonna go up, and looks like we are at 2, 4, I believe. So the moral of the story, f of 2 is 4. The value of function f at 2 is 4. So that will give us 4. And then we're going to add to it g of 2. And we're going to do it the same way. We're going to locate 2 on the x-axis. And then we're going to go up or down until we hit function g. So in this case, we're going to go down. And look at that. We have nice integer coordinates. So let me go ahead and label it to -5 if my eyes don't fail me. So the moral of the story is this: g of 2 is -5. So the value of this function at 2 gives us -5. I know that you can use your fingers if you like, that the sum of 4 and -5 is -1. So we want to tell the world f plus g of 2 equals -1. Fantastic. So we have 1 down, 3 more to go. We got this. Cool. Problem B, we have f minus g of 1. So what this is asking us to do is, let's go ahead, subtract these bad boys, and once we do, we'll evaluate it at 1. But we are going to apply the definition of the difference function. So we're gonna do it in a similar format. So we don't want the function side by side, we want them apart, and then we'll handle it. So the first function is f, and we want to evaluate it at 1. So this will read f of 1. The operation is minus, so we're going to subtract from it the second function and evaluate it at 1. So we're going to do it in the same way. Let's go ahead, locate 1 on the x-axis, and then we'll go up or down until we hit the respective function. So when x equals 1, f of 1. So it looks like this point is 1, 1. So f of 1 will give us what? The value of this function at 1 is 1. And we're going to subtract from it g of 1. Where am I? I believe that's 1, -4. So g of 1 will give us -4. Difference of 1 and -4, that's hard for me to do mentally. So let's go ahead and write it as an addition problem. Yeah, I had a technical difficulty. It's okay. Good thing I redeemed myself. Subtracting -4 is the same as adding 4. And the sum of 1 and 4, I believe, gives us 5. Fantastic. So 2 down and 2 more to go. We got this. Cool. Problem C, we want to evaluate the product at 0, so let's go ahead and split it. So we're going to take the first function, evaluate it at this number. The operation between them is multiplication, and then we're going to multiply it by the second function, evaluate it at 0. So we have f of 0. So when x is 0, the value of this function is 0. Okay. So technically, I don't even want to keep going because we know that 0 times anything is 0, but we're overachievers, so we're just going to continue the process. G of 0, I believe that's 0, -3. Okay, G of 0 gives us -3 because when the input is 0, the output is -3. Product of 0 and -3 is 0. So the moral of the story is that the product of functions f and g evaluated at 0 will give us 0. Fantastic. So for the grand finale, problem D, we want to evaluate the quotient at 1. So let's go ahead and rewrite it by using the quotient rule for functions. So that will give us the top function evaluated at 1, and we're going to divide that by the bottom function evaluated at 1. So f of 1, we already did that one. So f of 1 gives us 1. G of 1 gives us -4. Last time I checked, a quotient of 1 and -4 is still -1/4. We can't reduce it unless you're overachiever and you want to write it as a decimal. So the answer is -1/4, but in the book, the book wants you to put the fraction bar wants you to put the negative centered about the fraction bar. I don't really care. When the fraction is negative, you could put the negative with the numerator, denominator, or in the middle, in front of the fraction. Okay, so the moral of this story is that the quotient of f and g evaluated at 1 gives us -1/4. So we did it, guys. You guys are awesome. Thanks.